All right, Falcons. So this is the video directions. I'm going to walk you through everything for this assignment. That is the motion lesson for Monday, 10/19. So if we look at our Google Doc that was in classroom, we have some tasks. So number 1, write our agenda. 2, watch this video, which you guys are already doing. Okay. 3, do a vocabulary graphic organizer. And 4, do the Edpuzzle that is also linked here. So first start with the vocabulary. It will kind of help you set the scene for the Edpuzzle. All right, so I'm going to go over the agenda. So it is also on the slides. Let me get those loading. All right, so Monday today is you should be having async assignments from all of your classes and then homeroom. But make sure you follow your homeroom teacher's direction because a lot of us 8th grade homeroom classes have picture day and textbook pickup today. So make sure you know when that is. All right, so the rest of the week, I hope your teacher has gone over with you, but in case they haven't, we only have morning classes and homeroom every day this week. So the afternoon half-hour classes do not have because your teachers are doing parent-teacher conferences. So just make sure you know your schedule and what you're doing. And I'll only see you twice this week, okay? So today we're doing this motion lesson, and then we're going to get through the first 2 lessons of our new unit, which is forces and motion. So I'm excited to move on. I hope you guys are too. All right, let's look at our job here. So we have a vocabulary graphic organizer. You can fill it out on this document that I just realized I made a mistake and I already have it filled in. So I'm very quickly going to delete all that out. So you didn't see anything. All right. So we're going to fill that out right now. But I do want to give you the option. You could do it on paper if you want. So if you want to do it on paper, just make sure you have 2 columns and the vocabulary words. And then you can just take a picture, upload it to Google Classroom. Make sure I can read it, though. That's the thing. Sometimes you guys aren't so good about taking pictures. So we're going to use the slides to do that. I'm going to show you how. So let's just go ahead and open it up. Let's look at what words we're doing. We're doing distance, displacement, vector, speed, velocity, and acceleration. All right. So hopefully we already wrote our agenda. We're going to learn some vocab. Then we're going to make sure we learned it with our Edpuzzle. So before we get started, let's talk about what motion is. So motion is an object is in motion if it changes position in relation to a reference point. So a reference point is a place or object that is used to compare a change in object's position. So for example, from my phone over here, and I go like this, I know it has moved because it changed position relative to me. So I would have been the reference point there. Okay, so motion can be positive or negative. Think of like your number line in math, right? Like you can go positive direction. The video goes the other way. So positive direction, negative direction. I know you guys watched Mr. Voss dance on the number line. I was there for that one. And we struggle with positive and negative when we're making our videos. All right, so that's that. All right, so vectors. It's a weird word. Vectors are quantities that have both magnitude, that just means size, and direction. All right, so I know that that is one of the vocabulary words we need. So I'm just going to go ahead and copy that definition and come find the word vector here and paste. And I am fine with copy and paste. You might want to make it a little smaller. If you want to leave it huge, that's fine. Do whatever you want. Okay. Let's go back. So it looks like, so it's oftentimes used showing arrows. The length of the arrow indicates the size of the vector. So if I look at the blue arrows here, right, this one's a little bit longer. So like in this case, it represents the 4. And then this other one is 3. So because they're going in the same direction, I'd add those 2 vectors. So 4 plus 3 is 7. And then that would equal this green arrow right here. Whereas this 6 is this big one, right? But then if I have something going in the opposite direction, my arrow would show that. So vectors show direction. So it's going in the opposite direction. So it'd be 6 plus a -2, which was 4, right? And so that's why that's that green arrow. All right, I'm not going to try to, so I could copy and paste the blue as my example, but I'm just going to go to Google and find a better picture. So can you tell that I was just doing this? So vector quantities would be a good thing to search. Images. And I just kind of look, oh, that seems simple and easy. So I'm going to grab that. So copy image, put it in the box over here. Simple. All right, let's keep going. Okay, so now we're going to learn the difference between distance and displacement. And they look very similar, but they mean different things. Okay, so distance, the total length of the actual path an object takes during its motion. So that's the definition. I'm going to go ahead and copy that. Okay, a little trick here. If you right click and you paste without formatting, I won't have to change like the font. All right, so that's the definition. It does not depend on direction. So it's not a vector because we don't care what direction. So the easiest way to look at it is look at the picture. So here's a picture. So this is your house. This is your school. Okay? And pretend we could actually walk to school and go to school like we all wish. In this picture, the distance the student walked is 7 blocks. So if you look, this is how they walk. They walk here 1 block, 2, 3, 4, 5, 6, 7. Okay, so that is distance, the actual path that they take along the route. So I'm going to go ahead and for my example stuff, I'm going to take this picture and I'm going to put it right here. Okay, but then I'm going to add to make sure that I remember what the heck this means. So distance equals the yellow, which is, what did I say? 3, 5, 6, 7 blocks. Okay. Now let's go to displacement. Notice it's the same picture, so I'm going to definitely grab that picture and talk about the difference. So displacement is the length and direction of a straight line between the starting point of an object, starting and ending point of an object. So I'm going to copy that. That's my definition. Okay, I'm just going to go ahead and grab the same picture, put it here. But now let's look at the difference. So displacement does depend on direction. So it is a vector. So I don't care on displacement. I don't care the actual path that you walk to school. What I care is what the heck is the distance between the starting point and the ending point and in what direction. So notice it starts here, ends here. So like if you could walk through the park and walk through everybody's backyard on the way to school to get there the fastest route, that is displacement. So notice it has an arrow. So it does have a tip. It's just kind of hard to see there, but that is displacement. So it's the red. And if I were to count the blocks here, 1, 2, 3, 4, 5. It's kind of weird because it cuts the blocks in some different spots. Okay, so I'm going to put, I think I already grabbed, so it equals the red, which is about 5 blocks, probably a little under. All right. So that is the difference between distance and displacement. If you're still confused by those two words, I do have a video on slide 15 about it. So it might be good to look at. But let's move on because now we're going to look at the difference between speed and velocity. So most of us know speed, like how fast something is going. That's the definition. So let's go ahead and just grab that. It's the distance an object travels divided by the time it took. It's not a vector because we don't care about direction. When somebody tells you their speed, they're going 80 miles per hour down the freeway, right? Or it's a 25 mile an hour zone. Generally, we think of our car speedometer. So this is the calculation. So this is the equation. I'm going to go ahead and put that in my box right here. Okay. And so we don't care if it's 17 miles an hour moving forward. It's the same as 17 miles per hour moving backwards. I'm going to go ahead and grab that as an example. I'm going to put both in my thing, just because we can look at this later and it might be helpful. All right, let's keep going. We got velocity next. So velocity is also how fast an object is moving. How fast. So speed and velocity are both how fast. It's just that velocity also has direction. So that's the key difference, is that velocity has direction. So I'm going to go ahead and grab, this is my definition. All right, so it's the same exact equation. Distance an object travels divided by the time it took. So I'm going to go ahead and copy and paste that equation. And so it is a vector. It depends on direction. So I'm going to go ahead and grab the same, because it's the same example on the last side. So traveling 17 miles an hour forward is not the same velocity as traveling 17 miles an hour backwards. Sounds weird, but it's the truth. And the Edpuzzle that you're going to watch will kind of give you a little bit more visual on these two terms. All right, last word, acceleration. Most of you have heard of it, but acceleration is any change in an object's velocity. I'm going to grab that definition, put it right here. Okay, so it could be like an increased speed, positive acceleration. I always think of like getting on the on-ramp to a freeway, you're going to speed up. That's a positive acceleration. Decreased speed, it's called a negative acceleration, or you might see it as deceleration. That's like slowing down to a stop sign. Or it could be a change in direction, even if the speed is the same, because it does depend on direction. So like going 60 miles an hour north on the 101 is going to be a different acceleration than going 60 miles an hour south on the 101. It's kind of weird. Or anytime you do a turn, you're changing your acceleration, even if you're going at the same speed. We'll practice more, don't worry. All right, here's the equation. So I'm going to grab that and put it right there. All right, so notice my document is done. I don't need anything more on this document. I just need to still do my Edpuzzle. So the link is in Classroom, and this is what the video looks like. Just so you know, it's only 4 minutes. Watch it, answer the questions. All right, I know that was a long video, but I helped you through the whole thing, and I hope it helps you get it done and start off this quarter with a great grade. Let me know if you have any questions.